So we have Badger, the network security state estimation tool, with Edmond Rogers, Will Rogers, and Gabe Weaver.
All right, then. We got cut down from 50 minutes. Oh, well, yeah, I'm going to be really loud. Sorry. You had me on a high volume there. We put in a 50-minute talk. We got cut down to 25 minutes. But luckily, on occasion, I've been known to talk really, really fast. So I'm Edmond Rogers. I work at the University of Illinois in the Information Trust Institute, and so does Gabe Weaver. He has a PhD from Dartmouth, and we're researchers. And William Rogers is the primary author of the State Estimation Toolkit, and we all work together on this. So, what's the problem? The problem is hindsight is 20/20, and what we're trying to do is be able to get operators information in time so they can make decisions because they have too much data. I did critical infrastructure protection for over 20 years. And I never said that I had not enough time to review all of the data that my junk was already making for me. I needed a way to organize the data better. If only there was a way that I could better organize the data I was already generating and be able to send it to things that are tied into operations. So we started out with network security state estimation because I can't stand the word cyber. So I call it network security state estimation. But at work, they all call it cyber security state estimation. And what we want to do is measure the state of security. And I know this is a little bit of a argument point for a lot of my friends, but take it for what it's worth. Metrics are king. So we're going to play some hacker black hat Jeopardy, and here is the answer.
All right. It's an arbiter for core metadata on cyber physical systems. It also is a mechanism to share information in a human-readable, machine-actionable manner.
What is that? What is CPTL?
What is CPTL?
I don't fucking know. Why don't you tell me?
I'm going to tell you. It's a cyber physical topology language. And the challenge is we want to be able to integrate disparate sources of data. We use ontologies to facilitate this communication. And we make data queries via URL. So here's an ontology. This is a CPTL ontology. What you see are assets. Contained within the assets are IPs, ports, and devices as well. And we can add different things. We expect people to add different things into these ontologies to be more specific. Up here you see an ontology for the power system. We also have ontologies that the Badger uses. The Badger has its own ontology featuring things about network flows as well as about state. If you have Nmap, you can also start to fold this in. We're going to create an ontology for the kinds of information you find in Nmap. So you have these disparate sources of data. You want to be able to integrate it. This is how you can do that.
Right, and the key to the entire thing is, in the Badger, we make our own ontology about the things that we have information for, and we use CPTL as kind of like an arbiter or a rule set or a pseudo DNS server. We're all going to use the same terms because I may call IP something different than you do, so we want to be able to communicate state data about these different things so we can make better determinations about the state of any given IP address.
So right here what you see is it's not just about classes, it's about relations between those classes. And so we have a host that has an IP address and we integrate in the Badger state via that following relation.
So
when you look at this picture, what do you see? What do you see?
Handlers.
What else? Yeah, nice active audience. Good. It depends on who you are, right? It's all a matter of perspective, really. And so we can use CPTL to encode that perspective. If you're an infrastructure kind of person, maybe you see switches and servers. However, if you're running your own VMs and providing services, that may be what you see. Wouldn't it be nice if there was a way to integrate these two kinds of views and programmatically operate upon them so you can get a bigger picture? You can start to integrate. We currently can serialize CPTL in a variety of ways, one of which is GraphML. We also use RDF. So you're going to see it's really a flexible way to represent things.
And as far as the state estimation goes, we want to keep it simple. You know, red is bad. yellow, caution, green, and it's all good. We want to be able to send this state data out to diagrams in many different applications using the CPTL framework and the ontologies. So how it's going to kind of work is, so you're going to use CPTL, you can make a graph like we did here, and then that graph contains a construct, a query, and an ontology. And then on top of that, you can then query the Badger server, and then the Badger has a list of its capabilities and the attributes associated with those capabilities. And then within the Badger, there's a process where we use baselining and maybe entropy and some other proprietary means, and we store data on the state of IP addresses, for example. And then that security estimator can then send data into the graph and make colored state changes into other graphs.
So here's an idea. Here's a big picture vision, right? You have all these CPTL layer services, and the Badger provides all this kind of network state estimation information. One of these services may provide state information. Another may provide information about network flows. Yet another, maybe Johnny has some information about his own Nmap data. But today we're going to focus on the Badger, and the Badger is going to have two different services running, one providing state and another providing flows.
Yeah, we figured it's a good idea to concentrate on the Badger since that's what the name of the talk was. So the query kind of looks like this from a diagram perspective, and we're going to send a request from the client to the server, and the server is going to reply back with a list of attributes and things that we can do and the capabilities that the respective Badger server has. So it kind of looks like URLs, and we expect that you're going to be able to take these requests via a web server. And so, for example, for a given IP address, get the destination host names, and it'll throw up a little graph like this. Or you can also show a join through a different requested query, but the Badger is going to be on GitHub, and what we really wanted to do is just give you an overview of all this because we have a short amount of time. We're going to go right into the demo. So why don't you guys take it away with the demo?
All right. We're going to switch it over. This is always interesting. Boom. We're there. So kind of already described what we're going to be talking about today in terms of the demo, right? We have two different Badger servers. One is provides state information, another provides flow information, and we're going to be querying this information using the application called Cytoscape. But the first thing that we want to do
is we want to figure out what's on these Badger servers. So we're going to use a CPTL get classes request to figure this out. And this is going to tell us what types of information this Badger server can give us. So this is to tell us what types of information this Badger server can give us. So that we can see here that this is going to give us IPs, and that is defined in the CPTL core ontology.
Right, so the core ontology is the information that we use to integrate all these different kinds of information. So now that we know that this server provides IP information, we really want to figure out what kind of information does it provide about IPs in particular.
And to do that, we're going to issue the CPTL get relations request, and this is implemented as a Sparkle query. And this will tell us the different types of relations that this can give us. And now we see that we can get state and entropy, and those are both defined in the Badger ontology. So the next thing we're going to do is we're going to use Cytoscape to visualize some of this data. So what we're going to do is we're going to try and visualize this state data after we query it in Cytoscape. So when we execute this, we'll be able to see these IPs as nodes. And we can see these IPs. They all are nodes in this graph, and they have different colors.
What do the colors mean?
So the colors are red, green, blue. Green means good, yellow means questionable, and red means bad. And it's most likely that if this red is red, you're fucked.
Yeah, so if you're fucked, it's a bad thing.
When you get a chance to say fuck, you should really say it loud and into the microphone. Fucked.
Good. So now that we know that red means you're fucked, we're going to continue on our tour.
Right, and that query was it was sanitized data down from about 40 million lines of sniffer data that we had. We normalized it down to about 1,000 or 2,000 lines of source and host destination for a 5-node network like you'd see in somebody's house. So this would be like a representation of all the destinations you would see from a house.
So now what we're going to do is we know we can get state information from this source, but what can we get from the other source? What we can get is we can get flow data. So what this is going to do for us is it's going to give us the local devices on the network, and we're going to get some remote destinations that they connect to. So now we see that we have the local devices, and then we have the remote destinations that they're connecting to, fanning out from that. And this is a live map. We can move stuff around, and now it'd be nice to have a clearer view of this and to see which devices are connecting to what. So to do this, we can analyze this graph using Cytoscape, and then by doing this, we can see different sizes of nodes based on how many local devices connect to those remote destinations.
Right, so the dots change size is due to the relative amount of packets observed to each destination address. So what's next?
So it'd be really nice is to be able to say, okay, we understand which IPs are hit the most, but what's the state of those IPs? We need the badger. We need that state information from the original server that we were looking at earlier.
And so what he said, we can just integrate the state data, which we already seen, into the graph that we just made, and then we can view this data in Cytoscape after we integrate the two networks together.
All right, so what we're going to do is issue a query to get the state information. We're going to append it to this graph right here. I'm going to execute. You see it's coloring the graph. It's also going to show us, voila.
It almost worked.
Almost.
Right. So now we have all the nodes from the state and the network that we have, but we've already seen the nodes from the state, so we want to see a better view of our network that we created. So we're going to view this in a different graph, and now we can see that we have the different nodes and their states, and so we might want to look at some of the bigger nodes because those are the important ones because there's a lot of local devices that are connecting to those. And if those are red, that's probably a problem because we really need to worry about those because they could be really bad.
All right, so this gives us a way to quickly visually see what the state of these different assets are and kind of do a triage. So that's the first part of the demo. I want to switch it back to you.
All right, so at the university, this is also being used in some of the research that we do in my day job. This is an open source project, but it came out of some folks at the university we do research with. They wanted this idea of state estimation for network security, but nobody wanted to actually do the actual work of making the thing because it's really like applied science. So that's why Will and I decided that we were going to do this on our own and open source it to the community and just get an idea from the community about any ways that we can make this better because we are integrating this into our research at the University of Illinois. So, you ready to go, Gabe? So,
ready.
This is an RPE-funded project where there's a state estimator for the power grid that is being fed cybersecurity information from the Badger. And this is an RPE-funded 3-year project. We're about halfway through it. So go ahead and show them, Gabe.
All right, so we're going to hop back in to visualize this. And what we're going to do is issue a query to get the control center network for the model. And so what we're going to do is issue this query right now. So what you see is the versatility of the tool. You have the ability
so
to...
this is the IEEE. We based a lot of the research in the RPE on the IEEE 9-bus model. So it's a control center with 8 substations. And so Gabe's going to keep going along here so what's next, Gabe?
So what's next?
We only have a few minutes left.
Okay. So you mentioned, too bad, you mentioned we had substations, 8 of them. We're going to integrate one of the substations into this picture so you get a holistic view, right, of what the system actually looks like. So to do that, I'm going to issue another query here. And this will retrieve both a node breaker model as well as the substation network for a place called Ogdenville. What we're going to do now is append to the current network view, switch it over to the power, issue the query, and now you can see the control center network, the substation network, and the stuff you would see in a substation yard in a node breaker model. Now that we have that, what's the next thing we can do? Well, it's a similar story to before. Wouldn't it be nice if we could fold in some state information? So the first thing, and just so you guys get a better view of that, that's what it looks like. But the first thing I want to do is go do a query here to pull out, to annotate the thing with IPs. I'm going to append, and I'm going to go to right here and hit execute. And so now you see the diamonds, and the diamonds correspond to the IP addresses of each of those. Now we're going to fold in some state information. And how do we do that?
So we're going to do this same thing we did with the other graph, where we're going to query the Badger server who has state information, and then integrate that with the current network we have right now. And then we'll be able to see the state of some of these IP addresses.
All right, so I'm going to append to the current view, query this for states, and hit execute. Now we got the query result back. I just want to style it.
And if we select the network, we can create a new graph like we did before. And now we can see that some of the different nodes have different colors, and they mean the same thing as before. Green means that it's okay, and yellow means it's questionable, and red means it's fucked.
So you'd want to take a look at that. And so that's the kind of thing you can start to do with different types of systems. We're creating a language for that, and we're able to integrate state data with that through the Badger.
Right, and the idea behind all this is that it's not just about Cytoscape or this RPE project. This is much wider than just any specific vertical. We're trying to write this so that, you put together the applications that you have, you build an ontology, and you're going to be able to exchange information between those varying sources of information. And if you have to, you can make a Cytoscape map. We're going to have roadmaps for that in our GitHubs. And for example, we're also working with other research at the university where we have a firewall analysis tool at the university, and you can go to map.networkprocession.com and get a free map of what your network might look like. And then we're also working with these guys to do things like inject state data into these maps as well. So it's a really flexible framework for being able to both exchange now I have to drink, network security state data, and then to also ingest that kind of data from operations, because whenever I did this professionally, which was a long and very stressful career, I always didn't know whether or not it was important that somebody had owned something. You didn't know whether or not it was a toilet flusher in the plant or if it was something more important. And being able to make a decision in a shorter amount of time and giving operators the right decision in the right amount of time is very important. And unless you can put this data together so that you can get the information that you need within the right amount of time, you can make decisions that keep things from exploding. So we didn't know how long it was going to take. We didn't know if the demos were going to slow us down. So we wanted to also maybe save some time for questions. But there you go. And by the way, William is 15 years old, and I think he's one of the youngest Black Hat speakers ever. So if you have any questions, go to the mic. You probably don't talk as loud as I do. scared them all away, Gabe. Everybody wants to go drink. I understand that. So the slides are going to be updated on the Black Hat site after the talk, and you can just contact us through the GitHub, and then badger42.org is going to be up in a few days.
Oh. Someone's got a question?
We'd like to make Badger compliant. How would we go about doing that?
So if you have a data source that you want to make Badger compliant, what you would do is download the ontologies, take a look, and then if there is something that's not there, contribute to the project. And then there'll be a decision made so that everybody can use that type of ontology as well. You can share your ontologies back in the GitHub. That's the idea. Thanks. I chose the name Badger because this needed to be done, and I didn't give a shit, so it worked together. Because it was work that needed to be done, and so we just went forward and we did it, and we didn't, this was something that we did in our spare time, and because it needed to be done. Well, there's some of that too. But it's much more fun to say we don't give a shit.
That's a honey badger, right?
Yeah, that's the honey badger.
I saw a special on something after chat about honey badgers. They're really ingenious. They were locked up in a little enclosure, and he kept finding ways to get out of the enclosure every day. He came up with a different way. He kept changing the configuration.
Breakdown. Yeah.